Hey ladies and gentlemen, today we're going to be talking about parallel lines and their angle pairs. So let's begin. Now, the reason why we're talking about these is because these next videos that you can watch are going to be about angle pairs and their theorems behind them. A lot of times we use parallel lines to help us prove certain things that we want to prove in proofs. They're very commonly used, and a lot of times we use them for triangles, angle measurements, and things very similar to them. And a lot of times what you end up seeing is two parallel lines, which we have here, and those are the lines that are sort of noted by these red tick marks. Anytime you see those red tick marks or those red arrowheads, they're basically labeling those lines as parallel to each other. And what we have here as well is what we call a transversal. That would be this line. Okay, that line cutting the parallel lines is what we call transversal. And when we get oftentimes are these 8 angles that are labeled here for us. And these 8 angles are related to each other in such a way that we've been able to establish theorems that help us find what the measurements are to these angles quite easily. But first we need to understand, how do we name these angles? How are they related to each other? Okay, so the first types of angles that we're going to talk about are what we call corresponding angles. Okay, corresponding angles. And corresponding angles are angles that are essentially in the same location. Okay, so here we have two groups of 4. Corresponding angles are angles that are in the same place in each group. So for example, angle 1, the way I describe it, would be in the top left position. Similar to angle 6, which is in the top left position on the bottom. So we would say that angle 1 and angle 6 are corresponding. In the same way, we have angle 2 is on the top right, as well as angle 5. So angle 2 and angle 5 are also corresponding. I'm sorry, I just realized I wrote angle 2 there. It should have been angle 6. Angle 3 and angle 7 are also corresponding because they're on the bottom right hand side. So angle 3 and angle 7. And then finally, we have angle 4, which is on the bottom left, as well as angle 8. So angle 4 and angle 8. These are what we call corresponding angles. And we'll get more into how they're related to each other and what special properties they have in other videos when we address corresponding angles theorems. But today, we're just discussing these are corresponding angles. That's what we call these angles. Now, let's talk about alternate interior angles. So, alternate interior angles. Now, though, every time you see the word alternate, it often means that it's on the opposite side of this transversal. Alternate means that they're on opposite sides of that line. Interior refers to these angles on the inside. Interior often means inside in real world too. We're talking about whatever's inside of something else. So inside the two parallel lines, we have these 4 angles, 4, 3, 6, and 5. So the alternate interior angles are angles 3 and 6. So angles 3 and 6 are alternate interior angles. But also we also have here that angles 4 and 5. Again, they're inside and they're on opposite sides of that transversal. So these are the angles that we call alternate interior angles. The last group I want to discuss are what we call the alternate exterior angles. And these angles are going to be the ones that are located outside of the parallel lines. outside of the space created. So we're talking about angles 1 and 2 and angles 8 and 7. And again, the word alternate means they're on the opposite sides of each of those lines. So angles 1 and angle 7, they're on the outside of the parallel lines and they're on opposite ends of our transversal. So these are alternate exterior angles, angle 1 and angle 7. And then finally we have angle 2 and angle 8. Angle 2 and angle 8. And these are all of the different pairs that we see or that we get whenever we have two parallel lines that were cut by a transversal. So one thing to note here is that each angle has more than one pair. Most often they have two pairs. So here we can see, for example, that angle 1 and angle 6 were corresponding angles because they're in the same location with their respective groups. But also we can see that angle 1 and angle 7, angle 1 is also related to angle 7 as an alternate exterior angle. So these come into play later when we start talking about theorems. So hopefully now you understand what pairs are formed when we have two parallel lines that are cut by a transversal. The next thing you're going to want to do is to watch these next series of videos that talk about the theorems. And in these theorems we discuss how these angles are related to each other based on the quantity and the actual measurement of their angles. So do me a favor, check those out, but as always, thank you for watching and I hope you found this video helpful.